All right. Okay, quick. Where's the recording sign? Okay, so today what we are doing is on tutorial 6. So tutorial 6, the most important thing is to look at your two samples hypothesis testing. So these are the most important one. But we will talk a little bit about one sample testing as well. Okay, so this one sample testing is actually in your tutorial 5. The kind of questions will be you're doing a quality, what I call is a quality control type of questions. Okay, let's say is the average weight of something equals to a specific number. Okay. This is called the quality control type of questions. For two samples testing, you are looking at the kind of questions that will be asked. Okay. The kind of questions will be, okay, is the average of, let's say, group A equals to the average of group B. These are kind of questions. Okay. And what you have is for two samples, what's wrong with this thing? For two samples testing, group A and B are different. Okay. This is why we call this, okay, what is wrong with this thing? Okay. Okay. Anyway, let me get back. Okay. So group A and group B are different. They cannot be paired up. And this is why we call them as independent samples. Okay, the kind of question, let's say we give an example. Okay. Let's say that you want to find out whether chemical A and chemical B has the same, let's say, results in your cell culture. Okay, by same results, you may mean that the same growth rate or the same final cell count or something like that. Okay, so these are that. So the same cell tissue culture, the same cell culture cannot be treated with A and B. They are actually two different populations. Okay. That is your two samples. Sometimes two samples, we have this thing called a paired t-test. That means the two samples are dependent. So usually, this is before and after. Okay, so examples of such question will be, you are looking at testing whether an exercise program is useful in, for example, weight loss. Okay, so in this case, the same person will have the before weight and the after weight. Okay, so that is, it must be the same person. Sometimes in medical studies, we kind of don't have the same person. We use twins to represent the same person. So indirectly, I'm also trying to tell you that in fact, we've gone through this in the lab on Tuesday already. What you really do is you take the difference, which is, can be said that the before weight of person A minus minus after weight of person A. Okay, then you are testing whether the average of the difference equals to 0. If the exercise program has no difference, it's not useful in weight loss, then you expect that the average difference equals to 0. Which then, in another words, means that these two are the same type of questions. Correct? You're actually asking the same thing. Okay, so far, any problem? Okay, let me see. Save. Okay, one. Okay. Now, in two samples test, there is also t-test and z-test. Okay, your independent samples. There is also your t-test and z-test. Okay. When do you use z-test? Okay, you use it when there's two conditions that has to be met. Okay, the more important condition is the population variances or standard deviation are known. So this is more important. The second is sample size is more than 30. Now, which means that if sample size is more than 30, but the population variance is not known, you cannot use the z-test. Okay, so in this case, we are looking at your tutorial question 4. So tutorial question 4, the sample size is 50. Okay, but tutorial question 5. Yeah, tutorial question 5. Okay. Tutorial question 5, the sample is 31 each, but you only have sample variance. Therefore, you still cannot use your z-test. For your independent samples t-test, okay, there are two versions. One is with or assuming equal variance. Second is without equal variance. Okay. For t-test, there's only one version. Okay. It is always without equal variance. So when you want to do a t-test, you have to find out which one to use. Okay. So this is how you actually go about your data. First, you do to test whether is the variance equal. Okay. So in order to do that, you do a F test. Okay. If the variance can be assumed to be equal, then you do your t-test assuming equal variance. If no, then you do a t-test, assuming unequal variance. Okay, so this should be quite clear to you by now. So far, any questions? All right. Okay. So let's look at the F test alone. Okay. What am I doing? So let's look at your F test for variances. Okay. The common mistake that students will make is this. Number one, okay, you have to use the variance, not the standard deviation. Okay. Second, the F statistic must be more than or equals to 0, more than or equals to 1. Which means that the denominator must be larger than the numerator. The numerator must be larger than the denominator. Okay, so this is a very important aspect. Then your F test, I already told you in terms of the tutorial questions, is always a two-tailed test. Okay, this is for tutorials only, tutorial and exam. Always two-tailed test when you need to do on paper. Then you use the critical value is using your F distribution. Okay. F distribution has 2 degrees of freedom. Okay. So your numerator degrees of freedom and denominator degrees of freedom. So you have your F, the numerator degrees of freedom, and the denominator degrees of freedom. Okay. So it's very important. Let's say you take 0.05. Okay. How do you read your table? For example, we have 10 and 20. It is actually not equals to this is 0.025, make our life easier since we are going to use it all the time. Okay. These are not the same. So please do not read the table wrongly. Okay. So let's take a look. How do you read your F distribution table? Okay. So first you go to your F distribution table, which looks like this. So you look for the alpha value, this alpha 0.5. Go to look for alpha 0.025. Okay. Then V1 is the first degrees of freedom, V2 is the second degrees of freedom. Okay. So just now what we have is 10 and 20. Okay. So 10 and 20, this is the 10. Then we look for 20, which is here. Okay. So during your test, please bring 2 rulers. Okay. I keep mentioning. So this is 2.77. Okay. So this is 2.77. Let's look at 2010. Okay. So 20 is here. Going down. 10 is here. This is 3.42. is not equals to is 3.42. So please do not read the degrees of freedom wrongly. Okay, this is very important. All right, with that, we can do your tutorial questions. Okay. So let's start with question number 2. Question number 2, you are asked to what is the hypothesis of a test and identify the statistics to be used here. So can someone give me your answers? What is the hypothesis? The null and alternate hypothesis. Anyone? Hello? Am I sharing screen? I'm sharing screen, right? Yeah, I'm sharing screen. Okay. So anyone?
So this is the null hypothesis is self-measured data and directly measured data have no difference. Alternate is there is a difference between self-measured data and directly measured data.
No, okay. So look at the question. The height and weight are often used in epidemiological studies as possible predictors of disease outcomes. If the people studied are assessed in a clinic, height and weight are usually measured directly. However, if the people are interviewed, there's a self-reporting. So what you are trying to do is to compare between clinical measurements versus self-reporting. Okay, so you're actually trying to ask, do people kind of bluff in self-reporting? Okay, so our results, we are going to have something like this. We are going to have patient number. Okay, let's say we're talking about height and weight. We are talking about height. Okay, so let's say height, and this is also height. Okay, so one is from clinical measurement, one is from self-reporting. So patient number 1, patient number 2, we do both. So we want to see whether are there differences in the two methods. So in other words, what do you think is happening? Is it a two sample? Is it independent or paired samples?
Independent.
Huh? Depend. Speak loud. Speak clearer.
Independent.
No, they are dependent because it's the same person measuring twice.
Because it's like before and after like that, is it, Chair?
It is somewhat before and after, correct. So it's almost like saying, okay, when you do a survey, you're asked to report your weight. Okay, do you over-report your weight or under-report your weight versus a clinical measurement? Clinical measurement is like this clinical measurement, what we call it is as a truth, the real truth, but are you reporting it differently? Okay. So what you're trying to find out here is you're finding whether is there a difference between the self-reported and the clinical measurement. Is there a difference between self-reporting and the clinical measurement? How do you measure in clinic? Basically, the nurse asks you to stand on the weighing scale and then write down the values, so it's the correct value. But every time when you do self-reporting, fill up surveys, buy insurance, do you actually report the correct one? Okay, so in this case, we say that the difference can be the self-report minus the clinical measure. Then we are looking at whether is the difference equals to 0. So the null hypothesis is the mean of the difference equals to 0. The alternate hypothesis is then the mean of the difference is not equals to 0. So in this case, we are using the dependent t-test, also known as the hat t-test. Okay, now, how many of, I'm sure all of you have done some survey questions. Do you over-report or under-report your weight? Anyone over-report your weight? Anyone under-report your weight? Or you just give a rough estimate? The moment you step on the weighing scale, you are, okay.
Just give the number that is shown on the weighing scale.
But when is the last time you actually weigh yourself? Okay. Now, this is actually a very crucial thing. Okay. Now, ask yourself this question, more of the practical side. Do most people over-report weight or under-report weight?
Probably under-report.
Yeah, correct. So most people tend to under-report. That's true. Okay, we know that.
I feel like what they tend to do is basically use the last supported number rather than under.
Hello. Mute yourself.
Sorry?
Mute yourself unless you're talking.
I'm talking, yeah.
Okay, most people tend to under-report weight as well. Okay, same thing for health survey. Do people over-report or under-report, let's say, their smoking status? Do people over-report or under-report how much alcohol they drink? What do you think?
I think in any survey, in any health survey, they just want to give the better answer. Like if the question asks like how many times do you exercise, they want to over-report it. So anything that makes the person sound healthier.
Correct. Which is also a very important part. Okay. I wouldn't actually ask, but some of you have bought life insurance already, starting to buy insurance and all this. So this is actually a very crucial question. Okay. There's actually one question in insurance that asks you, do you drink alcohol? How do you think people answer this? Yes or no? How do you think people answer this?
They probably say very little or don't drink.
Because there's only yes and no, that's a problem. They never ask how much you drink.
If it affects the premium price, then they will say no.
Yes, correct. So most people say no, because if you say yes, the premium actually automatically goes up. When you say no, the premium is as it is, but what happened is for insurance company, when you say no, they already calculated that you drink something. When you say yes, it generally means that you're a heavy drinker. It's just like smoking. Okay, it's actually calculated. Even when you say no, it's actually assumed that half of the people will be lying. So that's a common problem, huh? So don't be surprised. Yeah, when I learn actuary, this is what happens as well. Okay, so question number 3. Okay. Enterococcus canis, an infection is tick-borne disease in dogs and sometimes can be contracted by humans. Among infected humans, the distribution of white blood cell is an unknown value, unknown mean with a standard deviation. The general population, the mean white blood cell is 7,250 per cubic millimeters. It is believed that a person that's infected on average have a lower white blood count. Okay, so what is the hypothesis? So what is the null and what is the alternate hypothesis? Anyone? Let's pick somebody. Grace?
Yes.
Okay, so what is the null hypothesis or alternate hypothesis?
Null hypothesis is mu1 equals mu2.
Why mu1 equals mu2? What is mu1 equals mu2?
The sample.
What? Okay, so what is sample 1? What is sample 2?
Mean.
Sample 1 is mean. Okay, can somebody help Grace? Okay, how about Joey? Joey? Lawrence?
Is it mu equal to 7250?
Correct. Mu equals to 7250 per cubic millimeters. Then what is the now alternate hypothesis?
Mu lesser than 7250.
Correct. Mu lesser than 7250. Okay. So what test will you use here?
One sample t-test.
Yeah. Right. Just one sample t-test. Okay. Grace, you understand what has happened?
Yes.
Okay. Basically, you're asking whether the infected population, on average, does it have a lower white blood count? Okay. All right. So let's go back to your question 1. Okay. Question 1A. Keith, true or false? Keith, where are you?
True.
True, correct. So question 1A is true. Okay. Sample size can be different. Okay. 1B. 1B. Let's have someone down the list. See. Okay, we have Grace already. Xuening?
False.
For what? Again?
False.
False. Yeah. Okay. Because if the T statistic is negative, for T test, you actually need to do an absolute. We have done that already. Okay, question 1C. Zirui.
True.
Okay, F test can be used to determine whether the variances for two samples are the same or not. That's true, correct? Okay. All right, so question D. How to pronounce the name?
Tansin.
Tansin. Okay, Tansin. Okay, good. I'm never going to pronounce your name correctly. Okay, because your name is actually hidden somewhere. Okay, true or false?
I'm not sure, but true.
Okay, why? Okay. The alternate hypothesis for independent sample t-test states that the difference is probably due to sampling error. Now, sampling error cannot be part of the game here. Sampling error means sampling bias already. It's something that has to be taken care of. So do you think it's true or false?
False.
False, correct. Okay. It's not due to sampling error. It's due to the underlying population differences. Okay. Okay, Rachel, E.
False.
False, correct. Okay. Oh yeah, forgot to ask you, how big is a bottle of coffee? Coffee. The coffee that you sell in CCND. Who are the coffee makers?
But 300 ml.
So it comes in a plastic bottle lah. Good.
Yeah.
Okay, so yeah, because I have to carry a few bottles. So anyway, yeah. So if anyway, I put on the form. I put on the form for next Fridays. But if I forget or whatever, just go and drink all 6 bottles by yourself. Okay. Okay. Then let's go to question 4. Okay, question 4 is interesting. First, do you use t-test or z-test? Okay, look at the question. The 2 different types of fish feed were used to test whether the difference in the effect. Feed A was fed to fish. Feed A was fed to fish in pond A, and feed B was for fish in pond B. 50 fishes were selected, and then their weights are recorded. Okay, so let's draw out the thing first. This is pond A, this is pond B, and your sample size, this is 50, this is 50. Okay, the mean is 3 kilogram, 3.2. Population standard deviation, which is sigma, is 0.1, 0.12. Okay, so are you supposed to use a 1 sample t-test, 1 sample z-test, 2 sample t-test, or 2 sample z-test? Nikesh? Nikesh?
Is it a 2 sample Z test?
Yes, correct. 2 sample z-tests. Perfect. Okay. So what is then your null hypothesis and alternate hypothesis? Okay. So in this case, the average weight for feed 1 or pond 1 is equals to pond 2. What you're looking is there a difference in the weight, right? So it's not equals to 2. Okay. And you're asked to test at 5% significance, so alpha is 0.05, but you have to divide it by 2. Alpha divided by 2 is 0.025. Okay. Since we have that, let's look at the critical value first. So the critical value is Z of 0.025. So can somebody give me an answer? What's critical value? This should be remembered well by now. Someone. Nikesh?
I'm not very sure. I put 0.1423.
0.1423. Okay, let's look at why you put 0.1423. Let's take a look here. Okay, 0.1423.
My larger variance over smaller variance is 1.07.
No. Okay, when you do z-test, there is no equality or non-equality of variance. You don't have to do that anymore. Equal variance or equal variance. Yeah, just go to the z-test yourself immediately. And what we want is the critical value for the z-test. So z equals 0.025. What is the critical value? Which means that
1.96.
right, 1.96. Please remember this, huh? When you have at the back here, this is 0.025. Automatically for z, this is 1.96. Okay. All right, good. Then what you do is you plug in all the numbers to calculate your z statistic. Okay, which is the mean of A minus the mean of B. Here you do absolute. Okay, divide by the variance of A over sample size and variance of B over sample size of B. Okay, then you put in all the numbers. In this case will be absolute 3 minus 3.2. Here is 0.1 square divided by 50 plus 0.12 square divided by 50. So what is your statistic? Okay, let's get the next person. Jia Quan.
Hi.
Huh?
Hello.
Yeah. What's the number? What's the value? If you haven't done it, then do it now. Okay. Great. What's the answer?
So he said he lagging.
He said he lagging. Okay, then somebody give me answer. Another person? Whoever that's not lagging.
So,
Yes.
9.05.
Correct, 9.05. So the conclusion is, do you accept or do you fail to reject or reject null hypothesis?
Reject.
Reject,
Okay.
correct. Yeah, it's correct, reject. So, but then you write out, since your Z is more than your Z critical value, you reject the null hypothesis Hence, you accept the alternate hypothesis. Actually, I should just rewrite this way. So you accept the alternate hypothesis. Therefore, you have to give a statement again. Okay, there is a difference in the two brands of feed. Okay, how many marks do you think this question is? Anyone? How many marks do you think this question is?
So I think 5.
5. Actually, it's 10. About 10. It can be 5, but it can usually about 10 marks. Okay, so where do you get your 10 marks? Okay, so this is 1 mark here, 2 marks here. The conclusion is 3 marks. Okay, here is 4 marks, 5 marks, 6, 7, 8, 9, 10 marks here. So this is where you get your 10 marks. Okay, so if 5 marks, then we just take these 2 as 1 mark, 8 and 9 is 1 mark, 6 and 7 is 1 mark, 1, 2 and 1 mark. So that will remove out 3 to 4 marks already. Okay, so you can't narrow down. So this is a 10 mark question, which is actually quite important. Okay. All right. So prepare for question number 5. Okay. So question number 5. Okay, let's look at the protein. We have high protein, low protein, and is 31, 31. The mean is 29.2, 27.3. The variance is 13.7641, 12.3201. Okay. All right. So, let's see, who asked questions? I feel that most people tend to report your weight. Okay, that's good. Right. Okay. Evina, what is the strategy to do this question? Do you have to do a F test? Do you have to do a T test, or what test do you?
F test.
F test, okay, correct. So let's do your F test first. Your F test, it is actually asking is the, okay, or rather, can the variances be assumed equal? Okay. So you also need your hypothesis. Your null hypothesis is that the variance for the high protein equals to the variance for the low protein. Alternate hypothesis is the variance of the high protein not equals to the variance of the low protein. Okay. Since you are testing at alpha equals to 0.1, alpha over 2 is 0.05. Okay, and the critical value, okay, we don't bother critical value first. Let's calculate the F statistic. So the F statistic is always must be larger numerator, smaller denominator. Okay, so it is 13.7641 divided by 12.3201. That gives you approximately 1.12. The critical value is then 0.05. The first degree of freedom is the numerator degree of freedom, which is 30 here. In this case, both are the same, so no difference. Okay, so let's go to 0.05 and 30 and find out. Okay, so this is 0.05. Now 30 is here. Okay, and you have here 30. So it's this 1.84. The critical value is 1.84. So do you accept or reject null hypothesis? Someone? Minli, do you accept or reject null hypothesis for your F test?
Hello. Can you hear me?
Yeah, I can hear you.
Okay, we say to reject.
Fail to reject, correct. So you say that since the F statistic is smaller than the F critical, you fail to reject the null hypothesis. Okay, hence you accept the null hypothesis. Therefore, the variances can be assumed to be equal.
So sorry, can I ask a question?
Yes.
Why the alternative hypothesis is not equals to, why is not greater than?
Because what we want to see is the variance equal, can be assumed to be equal or unequal. This is the question. Can the variance be assumed to be equal or unequal? That's the real question that we want. We really do not care whether is it larger or smaller than.
So there wouldn't be any one-tailed test in this kind of situation.
Correct.
But then like the question say about more of like increase of the weight like that,
Okay.
no meh?
Yes, so this is always the problem. As I mentioned to you in class on Tuesday, that F's test for equality of variance is a very rough test. Okay, there is about half of the statisticians feel that F test for equality of variance is always a two-tailed test. Okay, because the real question is being equal or not equal? But on the other hand, another half of the statisticians that I know feels that F test for equality of variance is always a one-tailed test. Okay? Which is why in Excel, all this is a one-tailed test. The reason that they gave is F test, F distribution is not symmetrical. Therefore, you cannot have a two-tailed test. Got what I'm trying to say?
Yeah.
Okay. This is why I put in the very first slide just now that for this module itself, okay, when you are doing on paper, F test is always a two-tailed test, but in computer, F test is a one-tailed test. Yes, it's very subjective. Because if F test can be a two-tailed test, right, then we will not care whether it's the numerator larger or denominator larger. It can be the other way around. Correct?
Okay, understood.
So that's a problem. Okay. So then we do the second part. Okay. We do a second part is we are trying to find out is if they let's say have this grams, right? Average weight for high protein diet equals to average weight for is not average weight for high protein diet is actually based on the question, larger than the average weight for the low protein diet. Okay. So in this case, this is a one-tailed test. So your null hypothesis is that the average weight is equals. Okay. Your alternate hypothesis is that the average weight of a high protein diet is more than the average weight for a low protein diet. Alpha equals to 0.1. Okay, so here what you need to do is do your S-square pooled first. Now your S-square pooled is a pretty long equation. You have your N1 minus 1 plus N2 minus 1 N1 plus N2 minus 2. Okay, so you put down all the numbers together, make sure you know which one is 1, which one is 2. Okay, so in this case, we have 31 minus 1. Okay, and our variance is, so the next line will be better. 31 minus 1. In this case, it doesn't matter because both of them sample size are same. When the sample size are different, make sure you be very careful with it. 13.7641 plus 31 minus 1. 12.3201. Okay, and you have 31 plus 31 minus 2. The final result you get is about 13.04. In this case, your degrees of freedom is actually N1 plus N2 minus 2, which is the denominator. Okay, so that gives you 60. Then you calculate your T statistic, which is this equation. You have your mean 1 minus mean 2 to absolute, square root of S square pooled multiplied by 1 over N1 plus 1 over N2. So in this case, it will be, we normally just take the larger minus smaller, 29.2 minus 27.3. Okay. 13.04, 1 over 31 plus 1 over 31 equals to about 2.07. Okay. And we have to find the critical value. The critical value will be T 0.1. Okay. And the degrees of freedom is 60. So that will give you 1.296. Now with this, do you accept or reject the null hypothesis? This is the T statistic, this is the critical value. Do you accept or reject null hypothesis? Anyone? Hello, anyone alive? Reject, correct. So say that since T is more than your T critical value, you reject your null hypothesis. Then you write all over again, except the alternate hypothesis. Therefore, you repeat, high protein diet increases rat's weight compared to low protein diet. Okay. Now, this type of question is about 15 marks. Okay, so where do you get 15 marks? Now, normally we just strike into half. Here is where you get your marks first. You get 1 mark here, 2 marks here, 3 marks here. So 4 marks, and the conclusion here 5 marks. And this is where you get your 6, 7, 8, 9, 10, 11, 12. This is your 13 marks here, 14 marks here, and your 15 marks here. Okay, so this is how you get all your marks. All right. Okay, so question number 6. Okay, so question number 6, we will not go through every single thing. Why not you give me your answers, 6 and 7, okay, give me your answers. If there's anything wrong, then we'll go through. Okay, so in this case, let's look at okay, what is the F statistic? What is the critical value? Your conclusion. So can somebody give us these answers first? Let's just have Junyang. Hello, are you there? Okay, Vivian? The first part. What is the F statistic?
Hello, can you hear me?
Yeah.
Oh wait, I was asking what was the question?
What?
I didn't get your question just now.
No. So I'm asking you for answer for F statistic for question 6. And your critical value for F statistic.
Hello?
Yeah. Yes, what is the F statistic?
I'm not sure, but got 3.87.
So explain to us how you do your F statistic. How you get 3.87? So which one is 3.87, critical or F statistic?
I also don't know.
You also don't know? Okay, can somebody help her?
Critical value is 3.44. Then test statistic is it 0.36?
No, it's totally, that one is totally wrong.
Sorry.
Okay. So your F statistic, you take 50 square divide by 20 square. The question gives you in standard deviation. You have to square it to give you the variance. Okay, so this is 2.78. F critical value in this case, it is Alpha divided by 2 will be 0.025. First degree of freedom is the numerator degrees of freedom, which is then 12. Second degrees of freedom is the denominator degrees of freedom is 9.
Cher,
What?
Cher,
What?
why is yours 20?
What mean why is mine 20 or 30?
Because the question is 50 square over 30 square.
Yeah,
Wait,
30.
right? Oh, never mind.
30. Yeah. Okay. Then this should be 3.87. Okay. So in this case, the final conclusion is the variance is assumed.
Joe, can I ask a question?
Yeah.
Isn't the critical value as 0.025 common 9, 12?
Cannot, because you have to find out what is the denominator degrees of freedom. Denominator, you're using 50. So the first one comes from denominator. Got it?
Oh yeah, okay, thank you.
Okay. So don't make this mistake. If you make this mistake, then it's going to be wrong, okay? All right, then what you want to do, find out is, are the two fits the same? So in this case, your null hypothesis is that fit A equals to average of fit A equals average of fit B. Alternate hypothesis is fit A not equals to fit B. Okay, two-tail test, your alpha becomes 0.025. Okay, so what is your S square pool? Your final result? Anyone calculated S square pool? We've already used up all the name already. Jen? Jen?
Oh, hi, what's the question? The S square pool.
Yeah. So you see my
What?
You asking me the S square pool?
Yeah, what is the answer?
Oh wait, I got it wrong, so I calculate now.
Okay.
Is it 1814?
Yes, correct. 1814. Then what is your degrees of freedom?
Oh, is it 21?
Correct, 21. Okay. Then your T statistic?
Oh, 3.907.
Yes, 3.907. Okay. All right. So finally, your critical value in this case will be you're using alpha of 0.025, degrees of freedom 21. So what's your critical value? Okay, get somebody else. Ishana?
Is it 2.080?
Correct, 2.080. So do you accept or reject the null hypothesis? This statistic, this is a critical value. So do you accept, reject null hypothesis?
Reject.
So Okay, so that's your answer. All right. Last question, question number 7. Okay. They do. Okay, question number 7. We'll do the same thing. Okay, in this case, question number 7, what test should you use?
T-test.
Yeah, t-test, but what kind? T-test, 2 sample or paired? Okay, paired t-test, correct. Yes, you're right. So you're supposed to use your paired t-test. Okay. So in this case, our null hypothesis is that the average difference is equals to 0. Alternate hypothesis, you are looking at whether is the weight training or is the exercise program useful. So it's less than 0. Okay. The difference is, or the D is actually your after weight minus before weight. Okay, because it's after weight minus before weight for the program to work, it has to be less than 0. If it's before weight minus after weight, then it should be more than 0. Okay, that means you weigh heavier before than you weigh than after. Okay, so that's what you're trying to say. Okay, alpha equals to 0.05 because it's one-tailed test.
Wait, sorry, Joe. So like in every situation, it's gonna be after minus before?
It's up to you. It's up to you. See which one is easier to calculate. It doesn't matter.
Okay.
But it must make sense, huh? Your now outer hypothesis and after minus before, all this must make sense. If it's a two-tailed test, then it's fine. It doesn't matter which one minus which one. If it's a one-tailed test, then it must be of concern. Okay. So in this case, our degrees of freedom is 9 because there are 10 patients. So our critical value is T 0.05, degrees of freedom 9 is 1.833. Okay, so let's look at our patients. Okay, we have a patient. So you have to write everything before, after. Okay, patient 1, before is 84, after is 80. Patient 2, before is 60, after is 55. Patient 3, before is 75, after is 72. Patient 4, before is 72, after is 65. Patient 5, before is 68, after is 68. Patient 6, 52, 55. Patient 7 is 45, 49. Patient 8, 77, go down to 70. Patient 9 is 69, go down to 68. Patient 10 is 66, go down to 59. Okay, then what you have will be different color. See the difference. Oops, horrible color. Dark green. The difference. Okay, the difference will be here -4, -5, -3, -7, 0. This patient put on 3 kilogram. This patient put on 4 kilogram. This patient lost 7 kilogram. This patient lost 1 kilogram, and this patient lost 7 kilograms. Okay. So then what you do is you calculate the average of the differences, you get minus 2.7. The standard deviation for the difference is 4.08. Then you calculate the t statistic. T statistic, you take the difference, absolute difference, divide by the standard deviation for difference and square root of n. That gives you the minus 2.7 absolute 4.08 over square root of 10. That gives you 2.09. So do you accept or reject the null hypothesis? Anyone? This is first. Huh? Accept?
Reject.
Okay, right. So since the t value is more than your t critical value, you reject the null hypothesis. You accept the alternate hypothesis. Therefore, exercise helps in weight loss. Okay, so that's it. Any questions?
Sorry, can I ask, right?
Yeah.
If the D I put weight before minus weight after,
Yeah.
but the alternate hypothesis I put is larger than
All
0.
right, that's also correct. Yeah, that's correct. That's fine. You can do this way, whereby the difference is equals to before minus after. Then your alternate hypothesis will be the mean difference should be more than 0 in order for the exercise program to be considered effective. Yes, you're correct. No problem. Okay, any questions? Let me just save this as well. Okay, if no problem, then that's all for today. So see you next week.
Thank you. Bye-bye.
Bye.
Thank you, bye.